All right, in problem number 5, we've got 1,000 lockers and 1,000 students. And on the last day of school, all the students met in the schoolyard and came up with a plan. All of the lockers were initially closed, and their plan was that the first student would run through the building and open all 1,000 lockers, and then the second student would run through the classroom and close all the lockers that are multiples of 2, beginning with locker number 2. And then the third student would run through the building and reverse the status of every locker that is a multiple of 3, starting with number 3. So what I mean by that is that, as far as reversing the status, is that if the locker was open, he would shut it. And if the locker was closed, he would open it. And then the fourth student would reverse the status of all the lockers that are multiples of 4, and so on. When all 1,000 students have done their thing, how many lockers will be left open? And how many will be closed? That's what we need to answer. Now this looks like kind of a tricky problem. Kind of a tough problem. But let's just kind of work with a smaller set of lockers and see what happens. See if we can find a pattern. So let's see. I need to this problem takes up a lot of real estate, so I need to scroll down. You guys will remember the problem here. So I'm going to make a little table. Let's say we have 10 lockers, or 12 or 14, I don't know. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, I don't know, that's probably enough. Okay, and this is the students over here. So this is student 1, and these are the lockers. And so, what does student 1 do? He goes through and he opens all the lockers. Now I'm going to use an O for open. So, open, 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 and so on. Okay, we could say dot dot dot. And then, okay, student number 2 comes through, and that student is going to close the lockers that are multiples of 2. So which ones is that student going to close? He's going to close this one. 2, 4, 6, 8, 10, 12, 14, 16, and so on. And the rest of them will remain at their current status, which is open. So the odds are open, and the evens are closed now. Student number 3 goes through all the lockers that are multiples of 3 and reverses their status. So locker 3 is open, so he's going to close that one. And then he's going to go to 6. That one's closed, so he's going to open it. 9 is open, so he's going to close it. 12 is closed, so he's going to open it. And let's see, 15 is open, so he's going to close it, and so on. Alright, so let's look at student number 4, and that student is going to look at all the lockers that are multiples of 4. Alright, so, okay, this locker number 4 is closed, so he's going to open it. And then he's going to go to 8, it's closed, so he's going to open it. Right? And then he's going to go to 12, it's open, so he's going to close it. And locker number, let's see, we just did 12, so 16 is closed, so he's going to open it. Alright. Well, let's just keep going through some more students here. 7, 8, 9. This takes a little while, but it's shorter as we get. So locker number 5, it's open, so he's going to close it. And then 10 is closed, so he's going to open it. And then 15 is closed, so he's going to open it. Alright. Number 6, he's going to, let's see, number 6, the locker is open, so he's going to close it. And let's see, he's going to go to 12, and it's closed, so he's going to open it. And let's see, that's as far as we can really go, given the numbers that we have. And let's see then, number 7. Alright, so locker number 7 is open, so he's going to close it. Right? And locker number 14 is closed, so he's going to open it. And so let's go to student 8. Student 8, locker 8 is open, so he's going to close it. And then he's going to go to 16, and it is open, so he's going to close it. Alright, and let's see, student number 9 is going to go to locker number 9. It is closed, so he's going to open it. And then he's going to go to 18, which is off our chart here, so I'm just not going to worry about that one right now. 10, 11, 12. Let's go up to 12, and then we'll see if we can find a pattern. See, I'm not carrying down the status of these other lockers, so it'll be easier, I think, to see a pattern when we carry down the status. But I'm going to go ahead and do 10, 11, and 12. So 10, okay, that's the only one, because there's 20 is not on the list. 11, okay, that one's open, so he's going to close it. And then 22 is not on there. 12 is going to go to locker 12, and he's going to close it. And so on. And, well, let's just go ahead, because there really isn't much to do for 13, 14, 15. Let's just go ahead and do the same number as the number of lockers, so 16 and 17. Alright, so we're up to 13. That one's open, so he's gonna close it. 14, that one is, let's see, that one's open, so he's gonna close it. Number 15, that one's open, so he's gonna close it. Number 16, that one's closed, so he's gonna open it. And 17, let's see, 17 is open, so he's going to close it. And you can see essentially this diagonal here is the final status, once I've done 17 students and 17 lockers. And you can see that if I carried those down, that's the final status, because once you get beyond once you get beyond like student 17, student 18 isn't going to touch any of the lockers between 1 and 17. He's going to start with 18, so all the higher number students are not going to touch these first lockers. So the first 17 lockers now are set, and you can see that which ones are open. So I see most of them are closed, but I see that locker number 1 is open, locker number 4 is open, locker number 9 is open, and locker number 16 is open. 1, 4, 9, 16. Interesting. They seem to be squares. So that might indicate a pattern, right? And so if that is true, that the lockers that are squares are open and the lockers that are not squares are closed, then it just boils down to a problem of how many squares do we have between 1 and 1,000. So we could count those. So we did 1 squared, 2 squared, 3 squared, and so on. And what's the biggest square less than 1,000? Well, I know 30 squared is 900, and 31 squared is 961, and 32 squared ends up being 1,024, and that's too big. So the biggest square that is under 1,000 is 961, which is 31 squared. So there's going to be 31 squares between 1 and 1,000. All right. So if if it's true that the squares remain, that the the lockers whose numbers are squares remain open and any other lockers are closed, then we would have 31 31 lockers are open, and then 1,000 minus 31 is 969. So we have 969 closed. That's given that pattern. Now, we kind of making an assumption that that pattern holds. So let's think about why would the squares remain open? And to do that, I want to change your perspective a little bit. Think of yourself as being a locker, and your locker number is, say, 24. Now, which students are going to touch you? Well, student number 1 is going to touch you. Student number 2 is going to touch you because he's touching all the multiples of 2. Student number 3 is going to touch you because you're a multiple of 3. Student number 4 is going to touch you. Student number 5 will skip you because you're not a multiple of 5. And then, but student number 6 will touch you. And, 7, 8, let's see, 8 will touch you because because 8 is one of your factors. And then what else? 12 will touch you, and 24 will touch you. Okay? So factors tend to come in pairs, all right? We have 1 and 24, 3 or 2 and 12, 3 and 8, and 4 and 6. So if you start out closed and you have an even number of factors, then you're going to be open, closed, open, closed, open, closed, open, closed. So you're going to end up being closed at the end, right? So if you have an even number of factors, then you're going to be closed at the end, all right? The only ones that are going to remain open are the ones that have an odd number of factors. And what numbers have an odd number of factors? Those are the squares. So like, for example, if you look at locker number 36, all right? So 1 is going to open you, 2 is going to close you, 3 is is going to touch you. Let's see, 4 is a factor of 36. 5 is not. 6 is, okay. And then 9 is going to touch you. And then 12 and 18 and 36. So those are the students that are going to touch you. And so that's an odd number because, the only factor that in here that doesn't have a pair, you have 1 and 36, you have 2 and 18, 3 and 12, 4 and 9. But 36 doesn't have, 6 doesn't have a pair because 6 is, or 36 is 6 squared. So you end up with an odd number of factors. Okay? So this one is gonna, so he's gonna open it, this guy's gonna close it, open, closed, open, closed, open, closed, open. Okay? So if you have an odd number of factors, you're going to be open at the end. If you have an even number of factors, then you're going to be closed at the end. All right? So that sort of helps you see why this pattern is, why it is that the squares remain open and the non-squares are closed at the end. So there you go. This is the answer. There are 31 open lockers when the students are all done and 969 closed.